All right, welcome back to System Software. We finished our system programming section, and now we're on to the midterm. So today we'll be reviewing everything you'll need for the exam. The exam is created. I have the answer sheet, and I've tried to make sure to cover everything that's on the exam in this set of questions. So we'll go over them today. Stop me about what you need more clarification on, what's more useful to you. But let me go over some of the mechanics first. So this will be next Tuesday in person. If you have accommodations with SAS, that will be uploaded. I still need to upload that, but that'll be uploaded. You'll be able to do that there. If you talk to me separately about needing to move it, I know we moved the exam, so most people don't seem to have a problem with it, but I think there are some people who still need to move it. Make sure to remind me. We'll do a makeup, a modified version of the exam for the makeup. But okay, here's the syllabus had some description of the midterm. Material will be taken from homework, projects, and lectures. We'll talk about final later. This is our in-class review. You can bring notes, make them reasonably sized. Don't play any tricks with, like magnifying glass or whatever. Don't put complete answers if you'd somehow figure out what the questions are. But otherwise, 8 double-sized pages. These should be letter pages, I should probably specify. Trying to avoid gaming. I'm sure someone will figure out ways to game this, but so 8 double-sided pages of notes. It's going to be held during class. This is the set of questions, the types. So there'll be 6 multiple choice questions, 7 short answer questions. So they might not be easy, but the answer will be no longer than probably a few words or a sentence. And there are 3 long answer questions, which could be coding, which could be long-form description, writing file trees, writing algorithms, writing C code. There'll be I like to have a separate answer sheet. It makes grading easier. And so I've put the actual answer sheet, what it looks like, so you don't have any surprises in the format. If people have issues with, as I do, with the notation and format of things, being confusing during exam day. So there's no surprises here on what the answer sheet looks like. So here's your 6 multiple choice questions. They come first. Here's your 7 short answer questions. I'm almost positive you'll be able to write in all of these if you have reasonably sized handwriting. And then there are 3 open-ended questions. So this question, I think this is enough space for you. I think this is enough space for you here in 15. And 16, this should be enough space for 16. These will all be printed individual pages, so the back will be available if you really need it. Scratch paper will be available if you need it. I'll try to make sure to bring extras of these. Sinan, remind me to bring extra, or Sinan print out extra ones in case people make mistakes. Make sure you put your name and your NID on each page, because I think we're not going to staple these just to make grading easier. So name and NID on each page. Questions about the format? Yeah. Oh, that's a good question. Yeah, I don't see why they can't be typed. Yeah, that's a good question. So this is what the exam answer sheet looks like, and then the exam question sheet, that's a secret until Tuesday. But it's sort of a subset of the content here that we'll go over today. Any other questions about the exam format? So, yeah, no other items, unless you have specific accommodations besides your writing implement and the paper on your desk. Put your full name and NID on every page. Can't emphasize that enough. Make sure you review the course policies about cheating and unauthorized assistance with coursework, including exams. So the exam's worth 8 points. So if you remember my clever little grading scheme for the class, a point in the class is 1 percentage point of your grade. And because there's 16 questions, I like nice, round, even numbers. Each question on the exam is worth half a point, regardless of difficulty. In the past, I found if you make harder questions have more points, then it actually makes the exam much harder. But so 16 questions, half a point each, so you can expect exactly how this is going to affect your total grade. Yeah.
Is it possible the long answer one you might have partial credit?
Say what? Yeah. We'll do partial credit. So I'll be grading the long form ones, or at least overviewing the grading. And of course, you can come to office hours, argue for grades. So they'll be partial credit, like 0.25 of a point or whatever. But I'll try to come up with a rubric for partial credit that applies to everyone. And you can always come to office hours and let me know if I make a mistake, if you make a mistake in grading, for sure, yeah. All right, other questions before we get to the content? All right, so let's go over the questions. File systems, what makes a Unix file system hierarchical? This was in the reading, we talked about this in class. What does this mean, and why is it the case? Yeah.
Because it's like each file is like a parent and then like its children in a sense.
So what are the types of files that can have children in this hierarchy? Directories. And what are directories? Are directories files?
Yeah.
Yeah, directories are just other types of files. And what's the content of a directory? A list, yeah, it's a list. It's a data structure. It's like a mapping, a dictionary between names. Yeah, it's related to the homework they had. So you can think of a directory as a single level tree, where the directory is a file that contains a mapping of other files. And so that gets at why it's hierarchical, because if directories are also files, and directories can contain any types of files, including directories, you can create this tree, this hierarchical tree of files and directories. And in fact, with hard links, it actually ends up being like a DAG, but for our purposes, we'll just think of it as a tree. All right, questions on that? And yeah, recall the homework that we had for that. We had a couple of pieces of homework, or just one bit of homework for that, where I asked you to look at a set of paths and reconstruct the file tree. So let's go into that. What's the difference between absolute? Well, first of all, what's a path in the context of a file system? It's like an address. So how does it work?
It's like how to go like get to the file from like through the other directory.
Exactly. Yeah, how to get the file through the other directory, starting from where in the Unix world? The root, or the working directory. Sure, or the working directory. So which is which? What's the difference between starting from the working directory versus starting from the absolute directory? Oh my God, starting from the root directory. I just gave the answer. Yeah. Exactly. Which is which? So which is the absolute? From the root, good, and the relative? Working directory. All right, very good. So that's the difference between absolute and relative paths. So if you're in a working directory, question, yeah. Well, they start with no slash. They start from the working directory. Why is it the case that? So why is it the case that if I have a relative path like let's just say bin hello, why is it the case that these two relative paths point to the same file? Yeah. Yeah, dot points to the directory itself. So it's not that dot slash is another way to specify a relative path from the working directory. It's just that you're starting from the working directory and then you're pointing to the same directory, and you can do that. That's why if you do dot slash dot slash dot slash, this will be the same file as this and this and this and this. These are all the same file because the dot is just a pointer to the directory itself. And actually, in that case, it's not just a DAG; it's actually a graph with cycles if you include these special directories. Okay, and so in that same vein, so this is how we reference the current directory. If we're in a relative path, or if we're in any path, then we want to reference the parent directory. Dot dot. All right, good. And so I may ask you questions like, here's a file tree. Let me get the notes from this. So we did this in class. So for instance, if I give you a file tree and say, what's the absolute path to Joe? What would you say? Yeah.
/home /Paul /home /Joe.
Yeah, good. So here actually the root was missing, but it's the same. Yeah, /home /Paul /home /Joe. So like right here. This part of the path is the absolute path to the Joe file. Yeah. Good question. So what's the difference between having the slash at the beginning and not having a slash? Yeah, so if it's a slash, it's an absolute path, which means it always starts from the root. If there's no slash, yeah, go ahead.
Sorry, I didn't. So if you put a slash, it doesn't matter. It's always ending in your absolute path.
Exactly. That's how to tell the difference. So that's why if you saw there was a little trick here in the homework 2 that said, here's your working directory, but we have an absolute path. So the working directory is irrelevant in determining the location of a file given an absolute path. You always start from the root. If there's no slash, it's a relative path. And relative to what? The working directory. So you have to know the working directory in order to use a relative path. So here, you might be asked to reference a file from a working directory or give an absolute path. Yeah. Yeah, that's a good question. So usually, so in most of the tools, if you put a slash at the end of a directory, it'll interpret it as a directory. It really depends on how you're using the file. So I think most of the time when you see tooling, they'll omit the path at the end. There are some tools where the slash does actually make a difference. But you can think of ending a file with a slash kind of designates it as a directory in some sense. But no, it's really part of the URL, the file separator for the URL. So the name of the file, for instance, does not include, the name of a directory does not include the slash. So if you look at the directory entries like here, this files is a folder as a directory, and the name of it does not include the slash. The slash is really part of the path. All right, and you may need to draw a file system tree, just like in homework 3, or homework 2, sorry. All right, questions on file systems? All right, so let's go over navigation. So I think we went over what the working directory is. What's the command in Bash for displaying the working directory? PWD, good, print working directory. All right, good. What about renaming a file? How do you rename a file in the Unix world? Move, MV. Good. What's tab? Sorry, go ahead.
It's the old name first and then the new.
Exactly, yeah. Old name and new name. And move also will move files between directories as well. Tab completion, what does tab completion do? Yeah, kind of auto-fills files, commands. Actually, anything. You can actually write a tool and write your own little completion specification and have tab completion work on your own tool. Yeah.
Hitting tab several times cycles through the options, right?
Hitting tab, that's a Windows thing. Hitting tab several times in the Unix world will, if it completes, it'll add a space, and then hitting tab again will give you all available files as an option, depending on the context of the tab. If there's not a single file that matches your prefix, it will show you all the available files. So rather than saying it, let me show it. So if I do LSP and I hit tab many times, it's going to show me all of the possible completions from this prefix. And then if I hit tab when there's only a unique completion, it'll give me the completion. And you can actually see it actually automatically puts the slash for me as well because it's a directory. Okay, so tab completion, you should all be using it. You should all be using the command line. I really want everyone to use the command line. I know it's a struggle for some, and I know some love it and some like it's a drag. But use tab completion, and it'll be a lot easier. Yeah. The first what? So how do you display the working directory? How do you? What's the command to show you the working directory? What's that? PWD. Yeah. So WD WD is the kind of abbreviation for working directory. PWD. To rename a file, it's MV for move. What's grep do? Does anyone remember what grep does? Yeah.
It like search the file for like given like a string basically.
And which file does it search?
The one you provided.
True, yeah. If you give it a file, it will search that file. What if you don't give a file? What file does it? Well, if I just say grep by itself, let's say I want to grep for the word hello, yeah. Standard in, yeah. This is the Unix convention that these standard tools use standard in and out, and so without any other arguments, running these commands, I mean, you have to give the match command, the string you want to match. Without any of the arguments, it just pulls from standard in. So I can just start typing in my bash prompt here, because when you run a bash thing, as we talked about last time, when you run bash and you fork a process from bash, it inherits standard in and standard out. So grep inherits standard in and standard out, which is my terminal. Now, a lot of these commands also allow arguments to be given as well. So the first argument is the string to match, and then the other arguments are the files you want to match. So it'll not use standard in, instead it'll use whatever file you open. Probably just redirecting it internally. I don't know how grep is written, but it may do something like that. You can actually grep all files with star. Star is like, will expand to all the current files. But anyway, this is, and you can use redirection as well, the file redirection. Okay, so that's what grep does. Grep matches a string in each line of the input file. So it does string matching for you. So the RE there, I don't know what the whole term is for, but the RE is like regular expression. And you can do some more powerful matching. I don't really know why it's called grep. Maybe global regular expression or something like that. I don't know why it's called that. But the RE part is like regular expressions. If you took discrete, you may have learned about these. Okay, how do you change your working directory in bash? CD, change directory. How do you change directory? Your home directory. CD slash. So what does CD slash do? What kind of path is it slash by itself? Absolute to where? The root. Yeah, very good. So what was your correction?
I meant to say tilde.
Tilde, yeah. You can also do just CD by itself, and it, good having good defaults. This is another kind of Unix or system design philosophy. Have good defaults. So CD by itself will just go to your home directory. And another trick that I was, trying to point out to, a student today. This, just for your own kind of speed hack, CD hyphen will go to the last directory you are in. So if you repeatedly type CD hyphen, you'll toggle back and forth between two directories. It's a little trick I use frequently. Okay, how do you delete a file in Unix? RM for remove. And how does this work? Is the content of the file wiped from your disk when you do RM? No. Why? What happens? What file gets edited when you type RM? The directory. Yeah, the directory gets edited, because the name of a file is not part of the data in the file. It's created by the directory, which maps names to files, and so remove can be very, very fast, because all you have to do is just delete the entry. It's like deleting a name from a phone book. The phone number's still there, but that association between the name and the phone book is gone. This is also why, like computer forensics experts can recover so-called deleted files, because they're not actually deleted from storage, the contents of them. Yeah.
Are there Unix tools like RM that will just like
Yeah, actually there is. There's a tool called Shred. Let me see if this is on Eustace. So this is the kind of standard. I guess it's a standard. Yeah, there's a tool called Shred, which so it doesn't remove the file by default. It overwrites the contents of it, which is really the only way to delete in the sense of removing the contents of a file. That storage medium is still there. And there are even, I don't know computer forensics well, but apparently even if you overwrite it once, the low level magnetism of if it's a spinning disk hard drive will have some remnants of the original setting that it had. So these shred commands will overwrite many times with random data and zeros. This is outside my expertise. This is computer forensics world. Also, if you try to do this on, say, an SSD, a solid state drive, unlike a spinning disk drive where you actually can tell it where, the kernel will tell where on the disk to make changes to the disk, The SSD will change where in the physical medium the placement of a byte of that disk is. So in other words, also the reason for this is that SSDs have like a lifetime of writing. They'll wear out, and so there's algorithms called wear leveling, which will change where you read and write files from, even if it's the same file. So if you open up a file and rewrite it, or you edit a file, it might actually be stored in a different part of the physical medium. So even if you try to do this on an SSD drive, your data may still be there and recoverable. So if you're worried about privacy, use encryption, use full disk encryption. I'm sure there are problems with that as well, but that'll make sure that the data is not readable without doing something to decrypt the data. But yeah, good question. So yeah, shred. Shred will, let me not do this. So shred will not even delete the file. It'll just, well, it has no contents in it, but it'll just overwrite the contents of the file, and then you can tell it to, with -u, I think, you can tell it to delete the file. But anyway, yeah, so yeah, good question. All right, any other questions on navigation? So know the common command, yeah.
Remove directories RMDir, right?
What's that?
So remove directories RMDir.
RMDir, yeah, good. Yeah, so just review the navigation section. There's like several tables here that show the command. So what does cat do? Prints and where does it print it to? Good. More. Does anyone remember more? It's like cat, but it does screenfuls at a time. Less. It's the same thing, but you can navigate backwards and forwards through the file. I don't think I asked about these on yeah.
Yeah, that's what I was going to say. So like when you ask which one shows the contents of the file, would be cat?
I mean, well,
Or would it be any?
there are multiple answers, right? You can use an editor, right? You can use VI to show the contents of the file.
All of them would we get one?
No, you can do a command. Yeah, of course. Yeah. You can't ask as an instructor, you can't ask a question that has multiple answers and then penalize somebody for giving a right answer. I mean, that's not right. That's not right. Yeah, and so I don't think I asked about these, but wget, you saw these in your example, so you should definitely know these. What does touch do? It creates a new file. It's basically making a new entry, making a new file that has no data in it, but it sets up the file in the storage medium.
Why is it touch?
I don't know. Well, touch also. So what touch does is it So let me make a new file here. Actually, let me go to where's my Scratch folder. So what touch really does is it updates the metadata of a file. So you can see it updates the access and modification times of a file to the current time. So that's like what the tool is meant to do, or like nominally it's supposed to do. So here I've got a README file that was made at 12:14. If I run touch on README, the file already exists. You can see now the README file is 1247. So that's what touch really does, but it will like by default create the file for you. Some design decision by the creator of this, yeah.
You can also just make a file with like your editor, right?
Yeah, you can make a file with an editor. You can make a file by redirecting to it, using redirection. So you'll see me do that a lot in class, where I made this new file just by using cat. This is kind of the beauty of these set of Unix tools. It's kind of like Lego blocks. You can arrange these however you like to achieve the same purpose or achieve lots of different purposes. You can build these up together without having to actually write any C code at all. You can just use these existing tools to solve common sets of problems. All right, other questions on navigation? All right, processes. So this is like the command line process stuff. So how do you redirect standard I/O to a file? So if you want to redirect grep or cat, how do you redirect file to files, to and from files? Yeah, greater than sign, less than sign. Which ones redirect standard out? Greater than. Which ones redirect standard in? Less than. Good. Okay. How do you redirect standard out from one command to standard in to another command? Pipe. Good. Yeah, the pipe command. So the vertical bar. So I always show ls piped to WC. What's WC do? Word count. What's ls do? list, ls, list. Yeah, good, okay. So, well, not everyone is calling it out. Some people are, but any questions? Any questions on this? Oh, sorry about that. This is my muscle memory of like show hidden files, show them in a list format with metadata, sort by time, reverse sort by time, and then human readable sizes. So I kind of worked this out like 10 years ago and just like remembered it rather than making an alias. Yeah.
What is the like double greater than sign or double less than sign?
Oh, that's append. Append, and then double input sign is a here document, but you don't need to worry about that. You can write a whole document until the end of it. But yeah, they're called here documents, and double greater than sign is append. So if I go to new file again, this is appended. Oops, I didn't append. This is really appended. So yeah, that appends. All right, other questions on processes on the command line? Yeah. Yep, exactly. LS pipe WC. That's exactly. So you take LS as standard out, which would have been this. So let's say there's 4 lines here, and then I can do to WC to do word count. Oh, actually, there's 5 lines. So this is the number of lines. Or I can pass it to grep and say, give me all the lines that have hello in it. And you can see grep will filter out the output of LS. Yeah. So greater than redirects to a file. So this is my output. You can see that's the output of the command. And then input. So if I search for 15 in this output file, that redirects the input. So I took this file, which the contents are here, redirected into grep, and it'll match all the lines that have 15 in it. Okay, editor. How do you edit files in Vim or Emacs? Let's get. I want to make sure everyone knows. I'm going to get someone new. Yeah. Vim, the name of the file. Okay. How do you quit Vim? Right. Colon WQ. Okay. Good. What's the difference between W and Q in Vim? Yeah. W saves to Q quits. You can even do them separately. What about Emacs? Where are my Emacs users? Yeah. Control X, Control C. That's how you quit. How do you save in Emacs? Control X, Control S. Okay. Okay. Good. Yeah. This is exclusive or, so one or the other. No nano. No nano. If you want the nano experience, use Emacs because Emacs is more WYSIWYG. Like you can use the arrow keys and stuff. I'm going to try to expunge nano from. Just look online. The kind of war. People fight about Vim or Emacs, but they don't fight about nano on the in the like kind of elite community. The elite Haxor community. But yeah, don't use nano. It's kind of slow to use. Okay, that's the editor. Not going to ask too much about that. I hope everyone is using the command line editor. I know it might be a little bit of a struggle, but hope everybody's using the command line. All right, build automation. This is one that we definitely should review because I think this one's pretty esoteric. Where's my question? Let me close some of this. Okay, so I'm sure everybody completely remembers this and has it imprinted in their mind, but the syntax of a make rule, this very esoteric syntax, what's the target for? Yeah.
It's like what the user will type in.
Yeah, it's what you type in. And it's what the user types in, and what is the target supposed to be after you type it? It could be your executable. It can be anything. It's supposed to be, it's telling make this is the file I'm creating. So when you say make hello, you're telling make that this is the file that I'm generating. And so that's important because if that other files depend on it, make is going to look at that rule to build that file. So target is the file that you're creating from this rule. So this whole thing is a rule that will generate some file. What we talked about in class is generating a program binary from source files, but it could be anything. It could be generated documentation. It could be publishing my course, which is what I actually use a build file to publish this course and generate it. Yeah.
I think it's good to mention, like if we're compiling main.c, it would be good to have the main.c as a prerequisite before we try to compile it.
Absolutely. Yeah. So let's talk about prerequisites. So, yeah, and actually, if you don't, so yeah, okay, let's talk about prerequisites. What are prerequisites? So, yeah, yes, guys, what are prerequisites?
Things you need in order to commit properly.
Right, things you need in order to build this recipe. So if this is, where's an example of this? So for instance, here, in this build script, if the thing I'm generating is the main executable or some file called main, the prerequisites are saying, in order to build this, you first need to build these .o files. So that make uses this information in order to automatically order the sequence of builds for you. So because you've told make, okay, I need these built first before I can build main, when you go to try to build main, make will automatically look for how to build each of these prerequisites. Yeah?
Is it correct to name the source? Because they are the source for the program?
So you definitely don't have to name the binary after the source files. And in fact, when you have a large program with lots of source files, you may not at all. So like Linux, for instance, I don't think there's any linux.c file, but the resulting binary, depending on how you build it, is called VM Linux. But all the files are called other things, like kernel scheduler or something like that. They're called other things. So yeah, you don't have to at all. You're free to make this whatever you want. You do want to make sure that this main is generated by the recipe you've written here, because otherwise, if something else depends on main, make is going to try to build it, and it's not going to work, and then your build's going to fail. But if it's the last thing being built, then it actually kind of doesn't matter. But yeah.
With the main recipe, could you say GCC main -o and switch those around?
Yeah. This is insensitive to the order of arguments and optional arguments. Yeah.
For the prerequisites, you said they have to be built first, but like, for example, the C file doesn't build. I mean, maybe, like how would that work?
Well, so this is how you actually compile a C file with GCC. The -c flag will just compile that source file. When you call GCC without -c, without any other arguments, so this is just telling what the output should be. It's doing more than just compiling. It's also linking it. And we'll talk about that after the exam when we get into how the system works. Yeah.
I more so meant like when you put it as a prerequisite for main.o.
Oh, yeah.
You said the prerequisites have to be built first, but in that case,
Well, yeah, I was a little strict in that saying build first. They have to exist on the file system first. And so if the file already exists and there's no build rule for it, then make will just use that file. So yeah, good catch. So this is kind of the leaves of the tree. That's how make stops building. But yeah, so if you have a file that exists already and there's no rule to build it, then it'll just use the file in the file system. It's just like super integrated with the file system because it assumes that, and there's no check on this, but it assumes that the recipe will create whatever the name of your target is. That's the convention. But yeah, good question. So yeah, this rule here is saying main.c is a prerequisite. It must exist. Not necessarily be built, but must exist before it. And if it doesn't exist, like in the case of these, or if it exists, but it's stale, the file modification stamp is older, or is older, and it needs to be built, older than this one, then it needs to be rebuilt. So it'll go out and build it. But yeah, good catch. You have a question? -o is just telling GCC the name of the binary to create. So without -o, what binary gets created? What's the name of the file? A.out. If you ever just ran, if you run GCC hello.c, you'll get A.out by default. So again, Unix philosophy, have good defaults or have a default. A.out is the default program that gets created. -o changes the name of that file. From A.out to, now it'll be main instead. Yeah. That's all this does.
That's an object file, right?
So technically, no, it's an executable. So we'll talk about that more in like next week. But yeah, GCC is doing a lot more than compiling when you run GCC. And one of the things it does is it links and creates an executable file that's ready for the system to load it and run it. Yeah, so the object files are just the compiled C source code to a binary. But we'll talk about that more next Thursday after the exam. All right, and then the last piece of the makefile, the recipe. What's the recipe? Well, technically this whole thing's called the rule. So more specifically, what goes in the recipe? What to do to do what?
Hit the target.
Yeah, to build the target. Yeah, the set of commands to run in order to generate this file. So now, strictly speaking, if you make a mistake, if you put hello here instead of main, then your recipe is sort of written incorrectly. Make's not going to check that. I don't know if there's a make static analyzer that will check that for you. But you can certainly make a mistake and not actually generate this. So for instance here, if I wrote gccc hello.c, main.o would not be created. And so every time you go to build main, it would think, okay, this is still missing. It wouldn't get created. But anyway, this is supposed to be the sequence of commands that make should run in order to generate the target. So just to review, the target is the file, the name of the file that you want to create. The recipe is the sequence of instructions that create that file. And the prerequisites are the files that should exist before you go to run this recipe to create the target. Questions on this? There's a whole bunch of other wrinkles with makefiles, like phony targets and all this stuff, which you just tell makefile that this will never be a file, so don't try to look for a file. But these are the broad strokes of what a makefile rule does. And the beauty of it is that you can declare how to build each part of your tool, including documentation or generated files, and build the make will figure out the order of things to run in order to build it for you. So especially to get into bigger projects, this kind of build automation is really key. It's annoying to maintain this in some script file, and kind of more brittle to do that. All right, other questions on, well, let's see what other questions I have for make. By convention, what's the clean target do? Yeah.
Like execute the commands that are under the clean target.
And what are those? Yeah, so what are those commands supposed to remove? What? Which files? Yeah, executables and binaries. The generated stuff. So by convention, clean removes the generated stuff. And you have to write that yourself. Sort of more modern build automation will help manage this for you, but in the make world, it's just done by convention. And then be able to write a make file that will, just be able to write a make file for hello world that has 2 source files. And so there's an example of this in here. This is building a binary from multiple source files. Yeah.
Do you want us to know about phonies?
No, you don't have to know about phony targets. All right, any other questions on build automation? Yeah.
Wait, can I see the command you did for making the linkers?
Oh, this one? So this step here is just doing linking. It's not actually compiling the source code because I'm just passing the object files. I'm not going to ask you this kind of detail about this part. This will be next Thursday. Yeah. Yep, you have the whole class time, 1 hour and 20 minutes. That's what's in my UCF. It's 1 hour and 20 minutes this semester, so yeah. Okay, what git command copies from the local repository to the remote repository? Push, good. Push. Which git command copies from the remote to the local? Pull. I think I didn't really, we didn't have to use this in class, but yeah, pull. Yeah, I'd accept commode. I'd accept clone too, yeah. So clone creates an initial, clone also does that. That's true. What about staging a new file? What? Add. And then which command creates a log of the change to a staged file to the local repository? That's commit. That's just a long-winded way to say commit. Yeah. then you can use add. You can use add to do that. There's like an interactive add. I never ever use this command, but you can do add to stage. I just use my Emacs integrated thing to stage stuff. But yeah, you can use the interactive command. I don't know any other ways to do it. All right, so that's version control. Other questions on Git? All right, let's get into the more recent, slightly harder stuff. Using the open syscall, open a path given the file, given some string in the file path variable. So how do you use the open syscall to do this? Can go into the using files. So here's an example of using open. That's how you do it. You just give the path and some. You can say read only. You can give anything you like here. I just asked for open. Any questions on that? That's literally just how you use the open syscall. Yeah.
Read only is not defined integer by one of the library.
Say again?
Read only is an integer, correct?
Is read only is what?
An integer.
I mean, yeah, these are all numbers, but this is yeah, these are all like.
Where is it defined?
These are defined by the system, but the whole point of having a name for them is you don't need to know the number. These are, oops. These are these are given to you here in the man page, has the full list of them. You can see here. So here's read all. Yeah. But I'm not going to ask you the details about those flags. We didn't really go over that in class. I basically just want you to, be able to write a system call. Okay, so, and then, how do you check for errors in the open syscall or other system calls?
Check
Yeah.
the error number. If it's not 0, there was a mistake.
Not quite. So the error number is not guaranteed to be written if there's no error. So don't check the error number. I saw this rumor going around. Don't check the error number to check for syscall. Yeah. Sorry, go ahead.
Check if the pointer is null.
Yeah, you check the return value of open. So yeah, don't check error no, because error no won't be written if there is an error. So if you had an older error that you recovered from, you may check error number and get some stale information. So the way you do error management of the system calls is check the return value of the system call. For most of these, it's -1. Some of them, it's not. You don't have to remember exact in detail the man page. Just remember the which syscalls there are, what they do. Yeah.
The F statement is standard error a file already in the system.
Standard error. Yeah. So why is standard error? Why can you be sure that standard error exists? It's part of standard I/O. It's part of the convention, and that is supported by the kernel. That whenever a process is created, you get 3 open files: in, out, and error. So as long as when the process is created, you'll be guaranteed to have an open file for standard error. Yeah.
Can we use P error?
Can you use what?
P error.
P error. Yeah, for sure. So I show this in class. Oh, this is fprintf. Yeah. Here's the error, the P error version. Absolutely, you can use P error. So if you sort of know this snippet of code, this kind of encapsulates calling system calls, checking for errors, printing out the error. So if you can do this, you should be good. Okay, so a little long-winded, but how do you use the read system call to read 200 bytes of a file that's already open? So let's say FD's already open. Yeah, how do you read 200 bytes from it?
You need a buffer, and then would you just loop over 200 times and just do each character individually?
Yeah, you can do that. That's like the Linux programming book had done that. Here's an example of using read. So you need a buffer. You can make a single character. You can have a 200 buffer. You can have a 100 if you like. Easiest way to do it is to just make a buffer of the size 200 and then call read, passing the file descriptor, the buffer, the number of bytes to read, and then here's error checking. But this is how you use the read command, the read syscall. So the main thing to remember here is that you assume you already have an open file descriptor from open. That's the return value of open. You need to give the kernel some allocated space, a buffer, and you need to tell the kernel how many bytes you want to read. That's the read system call. Okay, write a program that uses opendir and readdir to list the names of files in the current working directory. This one probably should sound familiar. So that's here. That's this program. So I know it looks like a lot, but there's only 3 commands. What are the 3 system calls you need to do this? Opendir, readdir, closedir. So what does opendir give you? Gives you this pointer to some structure. This is actually a library call. The manual page recommends not using the system calls for this, but this is a library call. It gives you this pointer to a directory. And then every time you call readdir, it gives you the next directory entry. So what system call will give you information about a file like, oh, sorry, question? Yeah. Yeah, I mean, ideally, yeah, you do the error handling. That's the right way to do it. But yeah, we can talk about partial credit when we get to the exam. All right, what system call will give you this? Yeah, size, number, hard links, stat. Yeah, exactly, stat. So there's an example here of using stat. I'm not going to make you remember like all these very specific data structures and return values. Okay. What syscall can you use to find the name of a file? Yeah.
For the name, I think
Yeah.
like pointer key_name.
Well, that's not a syscall, right? That's a data structure. So what's syscall? Yeah.
So you need to use opendir for to get the pointer of the directory, and then use the direct structure to get the down slash.
Yeah, so the trick here is just a reminder that files don't contain their own names necessarily. It's the directory that does it. So you would need to use opendir and readdir somehow. If you actually had an open file descriptor and you somehow didn't know the path, you'd probably have to just like search through your whole file system to like find that file somehow. Okay, questions on file system calls. So just know the main system calls. These are listed in table form here. These are the main system calls. You don't need what do you call it, a photographic memory image of the entire man page, but just sort of know how these system calls are used. Know that they you need to do error checking. Know that you need to give a buffer for read. Know that you loop over readdir over and over. Yeah.
On the exam, should we assume like all the header files are included?
Yeah, you can assume header files are included. Yeah. It doesn't have to be exactly compilable code, but you should have the system calls. The order of the inputs doesn't matter as long as you get the right inputs. The error checking should be more or less right. But if you don't have a memory of the exact, I don't want you to print out the man pages for all these. So don't worry about that. But just have the fundamentals of what their I/O is, and that's sufficient. All right, so processes, pipes, and system. Oh yeah.
Should we know a couple probably important defined variables from header files such as pathmaps?
No, you don't need to know it. Yeah. Don't worry about that. I didn't even show that in class. Okay, so how do we use standard syscalls, Unix standard syscalls, to create a new process that runs the ls command? Fork. Are we done? So let's say I'm bash and I call fork. Am I running ls now? No. Exec. Yeah, so you need fork and exec. So remember, to create a new running program, a different running program, in Unix, you fork. And what does fork do? Duplicates the existing process, including its program code. And then how do you change what process is running? Exec. No new process is created. It's literally just changing the program text. Okay. So same idea. So write a program that creates a new process where the original process writes the word parent and the new process writes child. So could you write that code? Let's take a look at the process creation. So this is that code. I mean, this is that code. So you call fork, and how do you tell whether you're in the child or the parent? The ID, the process ID that gets returned. Process 0 means you're in the child, or return value 0 means you're in the child. -1 is an error, and then otherwise you're in the child. So if you can, just remember that PID. Just remember the IO of fork. What is the input to fork? Nothing. You just call fork, and magically the kernel creates a new copy of that process for you and starts running it immediately. Yeah.
When we use fine, typically don't use the sleep and wait.
Which one? Sleep.
The sleep or wait on the process.
Nah, I didn't cover wait too specifically. Try to remember it, but it's not that big. Sleep is not necessary for this. This was just for illustrative purposes. Yeah.
So that would just literally just say print, like in just one shot.
Yeah. Yeah, that's all you do. I put s here or print. Yeah. Question.
So in that in case 0 when we're inside the child, do
Yeah.
we run any do we run extension inside?
Well, so if the question is just have the parent, I mean, you could run exec and exec echo or something, but a simple way to do it is to just fork and not exec, because remember when you fork, you duplicate the process except for the return value, and so you can do different things. So the parent process will run this code, the child process will run this code, even though it's the same program. They run different code, and why do they run different code? Well, there is file IO here, standard out, but why do they run different code? Why, if I call fork here, why is it that one process runs this code and another process runs this code, even though it's the same program? Yeah.
Their process is not the same.
They're not the same process, but they're running the same exact code.
It's the return value.
They have different PIDs.
They have different PIDs, true, but you mean this PID? Yeah, so the return value of fork is different. So the processes are identical, same running program, same position in the program, same open files, but the only difference is the return value of fork is different depending on which process you're in. And so even though we have the same program, as you know, if you have if statements in your program and you take different input that test, and the if statements test those, your program will execute different lines of code. You'll have a different trace through the program. So same thing here. The kernel will give a different return value to fork, and so even though it's the same program, they can run different lines of code. Yeah.
So when you fork something back, right, does it go back, so does that new fork process go back to the first line of that?
No, it has the same position, the same program counter gets forked. So when fork returns, you'll be at the next line of code in the program, but the return value will be different.
Okay.
So when PID, with the code to set PID to copy the return value of fork into the return value happens, that even though the program is the same, now its data is different. And so if your program is the same, but you have different data, then the program can take different paths through conditions. Yeah.
Where do they expect it to know all the different exact calls or not?
No, you can just pick one, and if you don't get the exact path stuff or environment wrong, that's okay. Just know that exec does not create a process. It just replaces, it swaps out the brains of the process. All right. So this is just saying, how do I write a program that replaces the current processes running program with a different program? What command does that? Exec, that's exec. Okay, so this is where it gets a little tricky. We talked about this over the last week. Write a program that opens a pipe and reads to and writes from it. That same pipe. So I didn't have this exact code in class, but you can just create a pipe and you have two file descriptors and you can just read to it and write from it. So it'll look almost exactly like this pipe program here, except no fork. So if you run pipe without fork, you still have a pipe. You can read to it and write from it. just like you can read to and write from any files. So in the same way here, I've got writing to one end and reading from the other. I can do that in a single program without calling fork. This is the version where you fork a process and do it between two processes. Okay, write a program that redirects the standard out of a program of its own process to a file called output.txt. I didn't show this exact code, but what system calls would be involved in doing this? So I have a was that? So who says fork? So any new processes? I'm not asking to create any new processes. So no fork. All right. Exec. Do we need exec here? No change in what program is running. And then I heard dupe. Who thinks dupe? Yeah. So what does dupe do? Well, it redirects any file descriptor. It overwrites a file descriptor with another file descriptor. So if you want to redirect the standard out, you can use dupe too. And so you can literally call open on output.txt. That'll give you a file descriptor. And then you call dupe2 to overwrite standard out with that file descriptor. So same thing we did with the pipe, except instead of redirecting to the pipe by using dupe, you redirect to the open file descriptor. So kind of to show pseudocode real quick, that would look something like open output.txt, and I know this is just pseudocode, this is not the full thing. Now we've got a file descriptor, and there's nothing stopping me, because it's a file, everything is a file here in Unix. I can use dupe2 to take this file descriptor and overwrite my, whatever it was, my standard out one. And done. And then any, I didn't ask to do this in the assignment, but any printing will end up going to output.txt. That's how bash does redirection. So same principle as piping, but a simpler context for it. All right, so I think I'm a minute over. Any last questions? So I know that was really fast, but hopefully you can look at the recording of this and look at all the code snippets I gave, look at all the sections in the text, and see you next Tuesday.